Hi everyone, my name is Sean Wildermuth, and welcome to my course, Designing RESTful Web APIs. I'm an author, trainer, and a Microsoft MVP since 2002. Are you embarking on creating an API for your website or mobile app? If so, just striking forward with your API could be a mistake. In this course, I will show you why designing your API first is crucial to a solid, built-to-last API with REST. Some of the major topics we'll cover include understanding the fundamentals of HTTP and REST, designing the entire API, including its URIs, verb usage, message bodies, associations, paging, error handling, and caching. Explain why versioning is so important to a successful API project. And finally, we'll talk about different security considerations for locking down your API. By the end of this course, you'll be able to design a REST API that will stand the test of time. This course is a great beginning if you're just getting familiar with REST and HTTP, but also going to help you design APIs before implementing them in the real world. I hope you'll join me on this journey to learn how to design RESTful APIs with the Designing RESTful Web APIs course here at Pluralsight. Welcome to the Designing RESTful Web APIs course here at Pluralsight. My name is Sean Wildermuth. I'm a Microsoft MVP, a speaker, and a filmmaker. In this first module, we're going to be explaining what REST is. In this course, we'll help you design a web API based on REST. We're not going to be delving into the details of how you would implement this, but how to design it before you implement it. I want you to understand REST's role in creating your APIs. And I want to introduce you to some key features of REST where you can be pragmatic instead of being dogmatic. I want to introduce you to some tooling. We're going to use this across the course to show you how certain REST API facilities work. There's a variety of tools that can help you test out these REST-based ideas. We're going to be using Visual Studio Code because it's fairly ubiquitous, but similar tooling exists in Visual Studio as well as in Writer. You can even use other sorts of tools like Postman. But we're going to use a very simple way of doing this, and we're going to create a new file, and I'm going to call it design.rest, or you could also say HTTP, but I'm going to say REST. They both resolve in the same way. And in order in Visual Studio for this to work, we're going to actually need an add-in called REST Client. REST Client allows you to use these files. And so let's take a very simple example. And so we want to call a pseudo API. I have one called cat as a service, and this will return me an image of a cat. And every request, to violate the way REST works, and we'll talk about that later, will give us a new cat. We can add to it some elements to give us more information. We could even say, give us a GIF of a cat instead. So the important part about what we want to do with the tooling here is go ahead and write out requests here and see how the responses are. In the case of these, because they're images, it's automatically showing them as an image. So now that you've seen the tooling, let's get into the meat of the course. So let's start with web development basics. This may be a review for some of you, but I think it's important before we get into REST to understand what underlies REST. The problem of working with distributed systems, which is essentially what REST-based APIs are attempting to solve, goes back a long ways, probably before some of you were born. So back when distributed computing really got started, believe it or not, in the 70s, the first iteration of this was called RPC, or Remote Procedure Call, simply a way to go to another server and ask it to execute something and return some result. In addition to these, they started with rudimentary versions of messaging and queues. So if you started to look at messaging and queues as a way to handle distributed APIs, you can see that this isn't new at all. Soon after, we moved into object-oriented APIs, and so COM and DCOM out of Microsoft, Corba and RMI out of the Java space. These were ways to remote objects instead of functions. This worked well, but tended to break some of the ideas about being lightweight and disconnected. And that is when we started to think about web-based APIs. So the original version of this was HTML HTTP. This was a new object inside of the browser that allowed you to make requests from the browser out to somewhere else. Soon after, REST was informed, and Microsoft came up with SOAP soon after, and they competed as a standard for quite a while. And most recently, GraphQL, gRPC, and some other technologies have started to emerge as different ways to write these. But REST, through it all, has maintained a level of commonality that most developers are still working with REST in one way or another, even if it's in coordination with GraphQL or gRPC or other technologies. So one of the first questions I like to ask students is, do you really need a web API? Are you building a website? Are you building a single page application, a mobile app? And if you're not doing one of these three things, why are you doing it? Are you creating web APIs in order to communicate inside of a data center or inside of a cloud-based application? Web-based APIs come with some overhead in that they're not the most terse APIs. And so if you want very quick communication between, let's say, containers inside of a Kubernetes cluster, web APIs might not be the right approach there. But there are tons of approaches where web APIs and, more importantly, REST APIs make a whole lot of sense. So let's start at the very beginning of what HTTP is. We've all typed HTTP or HTTPS into the browser in order to get to some public website, right? But do we really understand how it actually works? And so we have a client, which is represented by a laptop here, and it makes a request to some magic server in the cloud or in the data center or inside your organization. And this request contains three pieces of information. It contains a verb, what do you want the server to do? It contains headers, which is information about the request, and then content, which is actually the request. So as an example, you might want to execute a request that says, I want to create some data, and that's represented by something called a post. This is how big it is, so this is about the request, and then we're just going to send the content itself as hello world. And then it responds with another three-piece packet of information. Status code, which means did it work or not? Headers, which are, again, about the content that we're responding with, and then the actual content. So in this case, it would return a 201, which says, hey, we did create this. The kind of content this is text, and then we're going to return some piece of information, in this case, just the same object that was sent to us. The important idea here is this isn't a persistent connection. This is a single conversation to the server. And so the server itself is stateless. All it's doing is waiting for those requests to come in and figuring out how to fulfill those requests. So let's deconstruct it a little more. In the request, we have verbs, and the common verbs you're going to see are get, post, put, patch, and delete. And these represent different operations. The most common of these is get. Go get me the web page, go get me the JavaScript file, go get me the image, etc. Go get something. And this is going to be the same in APIs as well, where you're going to be making requests to some server and it's going to try to fulfill it. The rest of these are about changing resources that may exist on that server. So post is going to create a new resource, put is going to update a resource, patch is going to change some part of that resource, and unsurprisingly, delete is going to delete the resource. There are more verbs, but these 5 are the ones you're going to encounter most often. Headers are this metadata about the request. So this could be the format of the content, how big the content is, who's making the call, when it returns that content, what kind of formats or content types can it accept, any information about the request in the form of cookies, and cookies are going to be some magic string that contains data that the server may or may not need. And there's a ton of more headers, and you can create your own custom headers as well. And finally, the actual content sent to the server. By and large, verbs are going to be a single line of text. Headers are going to be multiple lines of text, and content is going to represent normally the vast majority of HTTP requests. So like we talked about before, this could be HTML, JavaScript, JSON, whatever it needs to be. And using content isn't valid on some verbs, most notably get. Get doesn't have content because it's simply a request. And so including a content section on a get is actually illegal, and most servers will go ahead and send you an error back about that. Content essentially is the information to help fulfill the request. So in the case of a post, which is going to create something, the content is going to be the data that's associated with that. And that doesn't have to be some specific format, right? It could be content that is JSON that describes some object, but it also could be an image or a PDF or any sort of file that you want the server to do something with. Store it inside of a data store, save it to a file system, send it on to some other server as well. Like all of those would be okay. And so when we think about this, binary and blobs are common. In the case of images, this feels pretty common, but again, it could be any sort of binary information. What about the response that we're getting back? The response is going to give us a status code about what happened. And these are broken up into ranges. So 100 to 199 are purely informational. You'll actually see these pretty rarely. 200 to 299 is success. Now 200 being the most common response status code you're going to get. And that is simply to say it worked. You're going to see some others that we'll introduce you to later, but this means it succeeded. 300 to 399 says you're requesting this in the wrong location. So redirection is saying, this resource is moved, this resource doesn't exist anymore, go find it here, whatever the case may be. So you're going to see some of those in the redirection section. 400 to 499, and these are where you can see some of the more common ones you're probably already familiar with, like 404, not found, is a client error. The client has requested something that the server has no idea what they're talking about. And then finally, 500 to 599 are the server errors. So you can think about 400 is something the caller did that was wrong, and 500 to 599 is being that the server failed in some way. The headers, just like in the request, is metadata about that response. This will be the type of content that is being returned, how big it is, when this content expires. So you might think about something as being stale or only valid for a certain amount of time. Cookies. So if cookies are sent to the server, they're most notably sent back to the client in the same form. And this way, the client can have some state that it can send with the request that it's going to get back. And there's lots more headers. And finally, the content. Just like in the request, it can be common types, blobs, but you can also have your own types in there, formats that only you, the client, and the server have agreed on about what those types look like. Let's take a look at this in practice. Let's see how this works in action. So we're back in our REST file that we looked at earlier in this module, and I want to use an actual site we're going to be using, and that is restdesign.dev. And if I just execute restdesign.dev, you'll see we get this very simple HTML page. Because we have other links like the CSS site, we can go ahead and execute that as well. But when we start to have multiples of these, our REST file, if that's the way you're using this, does allow us to create some variables. So I'll say site equals restdesign.dev. And in that way, I can, as we make more than one, I can just say site. And if we execute just the site which is going to use this, we're going to get that same old result, right? But if we wanted to look at a specific API, let's leave that get there and let's create another one. And let's go and just look at one of our really simple APIs that we're going to be working with, customers. Now notice this didn't get another send, and that's because we need to separate them by 3 pounds. This is important because what comes below this are going to be headers. So if I say accept application JSON, that is a header that will go with my request to the customer. So let's send that. You're going to see we're getting data back. And this is going to include other headers we're going to look at a little later. But it's important to see that we're doing just those simple things. We're using verbs, addresses, headers, and in the case of post, put, and delete, we can also put content here. So if we went up and did something like post to customers, it's going to say unsupported media type because it couldn't recognize what the heck that was. That's because we normally would put content type application JSON, and we run this, we'll get a bad request because, of course, this isn't JSON formatted, right? What I'd like you to take away from this is that when you're designing a REST API, you're still relying on those same basic tenets of HTTP. Verb plus address plus headers plus body equals an HTTP request. The format of this and how it's structured is going to be different. So if you now understand what HTTP is, let's talk about REST. The term REST comes from representational state transfer. These concepts include separating the client and the server, that servers are stateless, that requests are cacheable, and that the data you're going to be dealing with is using a uniform interface. This was introduced in Royal Fielding's dissertation, and that's where we get these concepts from. But REST has some issues, and I want you to know about these ahead of time. A lot of times, because of the concreteness of what was defined in that dissertation, it can be too difficult to be perfectly qualified as being REST or RESTful. This ends up being an argument about dogma instead of pragmatism. And if you've ever taken a course from me, you know that I like pragmatism over dogma. This means we're going to use a structural architectural style that needs to be productive so we can get our jobs done. So we're going to use enough rest to do our job. And we're going to mention and sort of float around the corners of some of the things that are more complicated that a lot of developers are just never going to use. Let's take a look at a well-designed API next. So let's dive into a well-designed API. Back in Visual Studio, I'm going to create a new section here, and I'm going to say get https github.com help. So this is an API that GitHub exposes, and I really like how theirs works. Doesn't mean you're going to need to use every facility that something as public as a GitHub API does, but you'll see some of the good decisions they made in designing this API. So when we execute that, we're getting a lot of header information, which we're going to ignore right now. But we are getting a file not found, right? A 404 is the classic could not find this endpoint. In fact, it tells you not found and sends you back to the documentation for REST so you can help figure out what you did wrong. Now, help isn't an endpoint, but users is an endpoint. And you see it returned yes, and it returned a number of different users that are public. Now, we didn't do any sort of carving down into this, but what you'll see is if you look at the URL, users just have the username after that. So let's look at my record inside of GitHub. And what you'll see here is that has information. All of this is public. So what we're dealing with here isn't necessarily private information because we haven't logged in or authorized or any of that. But one of the things it likes to do is give you links over to common things you're going to need. Like I could click over to these and it'll open up in a browser. Or if I do something like just copy it, create another get, and send that request, you can see that we now have a list of those followers. I don't have too many, but you can see we're getting that same information for different people that are followers of mine on GitHub. And one of the things you'll notice here, if I make this a little smaller, is that it's following this pattern of getting at some collection, getting at an individual user of that collection, and get a collection that's related to that user. We call those association APIs, and we're going to be talking a lot more about those later. And so what if I wanted to delete my account completely? I could use a different verb here for delete, right? And either all my repos are about to disappear, or it's going to tell me that it's not found. And that's because you cannot delete users in this fashion. There's different APIs for supporting that. But more importantly, I'm not authenticated. This is all public information we're dealing with right now. And if we went ahead and used some authorization information, we might actually be able to do some of these things. One of the couple things to think about that I like about the way that GitHub works is it has this notion of collections that have individual items that have other collections, and that may continue down the road. It's treating each of these different users or different collections or objects on those users as a different way to get at those. And so when we look at this, it should be pretty clear what we're looking at. So as a developer using this, once you see what those patterns are, it can make a lot more sense. For example, you see all these links it's giving you, right? So we can really see that our gists, our start URLs, those are all patterns that we can use to get at different data. So if I wanted to look at all my repos, it would just be following this. And the benefit here of including those URLs in the object or not is really dependent on how you're working. If you're creating an API for a small set of users in order to facilitate a spa or some other thing in your organization, you might not need to get this complicated. But when you're creating rich public APIs, you might want to go the extra mile to include more information than you might imagine. Let's wrap up this module. So what have we learned? We've talked about how communicating between two computers is not a new problem at all. It goes way back almost 50 years ago to the initial ideas about RPC, messaging, queues, those sorts of things. And that REST represents a way to do that in today's world where we can communicate over the same ports that web browsers do. I've introduced you to HTTP as a way to show you the elements of what HTTP does and how it works, so you can see how that applies to your REST APIs. Because REST lies on top of HTTP, it's going to be important that you keep HTTP in mind when we design our REST APIs. And I've shown you a well-designed API like GitHub has because I want you to see that designing your API means more than just creating an API endpoint and writing some code real quick. You're going to want to give some forethought into what that looks like. Next up, we're going to dig into designing a REST API for ourselves. Welcome to the second module, Designing a RESTful API. Now that you've learned some of the basics of how RESTful APIs work, let's go ahead and create one of our own. In this module, we're going to start by designing an API first. This means designing the requests, the verbs that are part of the request, the nouns that are part of the request, also known as resources, the idea of idempotency, then we'll design the results, and we'll format the results. Let's get started. So you've heard me talking about this all through the course so far, and that we want to design the API first, not after. The reason is you can't fix an API's design after you publish it. It becomes too easy if you haven't planned ahead to just add endpoints as you think you need them instead of designing something that's flexible for users to use. This also helps you understand what is needed in an API instead of just starting to write. And if you design your RESTful APIs correctly, they can mature and be long-lasting, which often is the goal for any API project. We hinted at this in the previous module, but REST APIs have these parts to them just like an HTTP request. We have the URI, which is a uniform resource identifier. This may also include query string parameters, and we'll talk about the difference between those as we go forward. And then some verb that's related to it, just like in the HTTP request. There may be headers, and there may be a request body. Now, this request body isn't supported on all verbs, but pretty much any verb except for get will have a request body. The thing that's returned is a status code, headers, and a response body. Knowing these individual parts of your API, request and response, we're going to need to think about and design each part of our API, not just the URIs and the status codes. So let's talk about URIs. When you're building a REST-based API, URIs are simply paths to some resource. So if you have a yourserver.com, you might be returning the people that are related to your company. You're going to be returning a resource of the people that are part of your organization. In addition, you'll see query strings are used for non-data elements. So this could be what format you're going to get it in, what sorting, searching, and paging. Those all may be used in query strings. And query strings are separate from the URIs in that all query strings should be optional. If there's something that's required as part of your URI, it should be part of the path, not part of the query string. So I keep using this word resources. What do I mean by that? This could be any real world object like a person or people, invoices, payments, products. Those are all things that we need to represent inside of code. And the REST API is just allowing you to have access to them. So when you look at that, you might think, oh, each person is just an entity in some data store. Especially if you come from certain worlds where you're using ORMs, you think about this one-to-one modeling, but it's not really true. So it could be a person, but the resource itself has some context around it. And I don't mean in the domain-driven design notion of context, though they're similar. I mean that when you're reaching out to get an entity, it might not just be one row in one table in one database. This whole thing ends up being a resource. So you can imagine it being like invoices and invoice items or order and order items, right? They're together going to be considered a resource. You're very rarely going to need to get one invoice item without getting the invoice itself. This could also be any sort of hierarchy. So in the example we're going to see, we have several types of objects. We have customer, like we've seen, which is its own object and its own resource. We have this context around projects and the tickets that belong to them. A project might be a work item that needs to be done, and the tickets are each of the hours used to fulfill that project. And so we can think of them as being contained together. And then employee, like customer, is going to be its own sort of resource. So let's talk about identifiers in URIs. The idea behind identifiers is a way to locate an individual resource. This makes the URI a unique identifier. So when we think about identifiers used inside the URI of some API, these don't have to be primary keys. This can be anything that you can use to identify the resource. So we have some examples here, whereas customers in our case is going to return that collection using an ID after customer says this is the customer who has the ID of one. Or it could be having the customer name of Microsoft or having the stock ticker of Microsoft. You can decide what these primary keys need to be, and that is part of that design process to really understand how to uniquely identify them. The only caveat here is that for customers one, customers Microsoft, customers MFFT, whichever scheme you use, it needs to resolve to one and only one resource. Now that we essentially understand how URIs work, let's talk about query strings more in depth. So these are specially used for non-resource properties. So you could use them to say, hey, I want to include some more data. I want to get the first page of that data, etc. And so you can see query strings, because they're not required, you need to be able to use them for cases where you want to infer some information to the API that is not necessarily about the entity, but how you want to get the data back from the entity. And you can see here, paging is a super common case, including projects to shape the kind of data. You might even specify the format or a search string to search for. All those are part of that query string, because we can't treat query string items as anything but optional. Let's see this in practice. So let's show you some examples of URIs. I'm back in my REST file that I'm going to use to show some of these examples. And we've seen this before where we're just getting API customers, that the site plus this string is in fact the URI for the collection of customers. And that's why we're returning an array of customers, right? Each customer is atomic, and I'm returning a collection. And when we think about the URI for a collection in this way, this is the way we would design it. But if we wanted to be able to get one in particular, we're going to need to have a way to identify them. And I've chosen to use numeric IDs. You could choose whatever you want. And when I execute that, what we're going to see here is a single customer is returned. So this becomes the identifier for this particular customer. In practice, this isn't a crucial thing for me because this URI is pointing at a singular resource somewhere in my system. I want to make sure that I don't reuse these keys. So if for some reason we lose this customer, I probably don't want to then make a new two and have some problem in my URI that I'm starting to identify two different customers by the same number. And you'll notice, even though I have the customers here, I'm not returning the projects. It's ending up being an empty string because by default, if I want the customer or the customer list, I very often don't want to get down into the details of the projects and tickets and all those other parts of the API. But if I come here and I say customers include projects equals true, so I have this optional identifier to say, do I want to include the projects? And now that same identifier is going to have a list of those projects. Now, for some, they don't have any projects, so it's not going to include them. But for any customer that already has one or more projects, it's going to include it in our result. Now, it's up to us to know that this URI is pointing at the list of customers, but also saying this query string to change the behavior of the default API as it returns. And making this consistent is important. So if I'm looking at customers 1 and I say include the project, it should also include the project. So it should work at every level of our API. Make sense? So let's talk about how verbs and REST work together. This might review because it seems a lot like what we talked in the last module, but I really want to tie these ideas together. A get is to retrieve a resource, post to add a new resource, put to update a resource, patch to update a resource with certain changes, and then delete to remove the existing resource. And if we think about the way this works, this very much models to a lot of us are used to in dealing with data stores, where you're doing a select, an insert, an update, and delete. And these verbs are separate from the URI itself. The URI is going to point at, let's say, an individual customer. And when I do a put to that customer URI, it expects that the body there is something that's going to update that resource. Or if we use the verb delete, the URI is still the same, but we're deleting that resource itself. So how do they actually work when we look at this? So if I have a resource like customers, the different verbs we're talking about here do different things. So get gets the entire list. Post creates a new customer. So when you want to create a new customer, you're not going to post to an individual ID. You're going to post to the collection. A put could be for updating a batch of customers, though this is more rare. And then a delete on customers should be an error almost in every case. You don't want someone to accidentally delete all the customers in your database, for example. When we're going to look at an individual resource, a customer with an ID of 123, when we get that item, like we saw just a minute ago, it's going to return just that item. If we try to post to that item, it should return an error because we can't create a new item on this item. We'll see later how we could create related items, but we're just talking about single resources right now. And then put will update the item, and delete, unsurprisingly, will delete the item. Let's see this work in practice. Let's use verbs. I'm going to copy this request so that we have them all in here. And if you haven't used REST files before, you separate each request with a triple pound sign. And if I just say post here, let's get rid of that include project and run this. Method not allowed. If you notice, the server is returning me what I can do on this. I can delete, I can get it, and I can update it. But that's not really what I'm interested in. What I'm interested in is being able to create a new one. So I'm going to change this back to get so we have them all in here so we can get them each if we need them. And here I'm going to do a post, but of course I need to post directly to the customer's collection. And including headers are important. I'm telling it with this accept header, like we saw earlier, that I want any data that's returned to me to be JSON, but I also want to tell it the content type being application. JSON as well. For the most part, when you're using some framework to build these APIs, whether you're using Node and Express, whether you're using .NET or Java or Flask, it's going to do the header information for you pretty easily. You're not going to have to design each of these, but I want you to really see what this looks like. And what I'd like to do is I'm just going to make a copy of this real quick, just so I don't have to retype from memory an entire content. After that blank line, I can go ahead and put a body here. But because I'm creating a new one, I'm not going to include the ID because it's going to give me the ID back. And I'll call this Wilder Minds. I'll make it me. And I'll give you a real phone number. And the rest of it I can leave alone. I'll go ahead and put USA here just so we know that it's going to update it. And if I post this and I send this request, it'll say it's created and we have our new number ID of 28. And importantly, it also includes this location header that gives you the URI of the actual customer we're dealing with. So we could use this URI when we retrieve that back to know that this is the URI that I would do a put, delete, or other operation on. If we go ahead and create a put to this ID, and you'll notice that I've changed the city, state, and the postal code. I want it to just to update those. I don't want it to create a new element. I don't want it to change the identifier, none of that. And let's make sure that the IDs match, and let's go ahead and send that request. Now the data we got returned with that good city, state, and postal code, right? But if we come up here and get this again, let's go ahead and get this individual one, we'll see we're getting that same element exactly the way we would expect. Finally, if we delete this element, we can go ahead and send that request and it'll return back that it's been deleted. So the customer 28 doesn't exist anymore. And we know this because if we go get request for 28, we get 404 not found. Make sense? Let's talk about item potency next. So there's a concept in REST and in other parts of computer science called item potency. This means that some operation can be applied multiple times without changing the result. So as you execute this, it expects the result to be the same every time unless there's a state change outside of your control. So in REST, this means that operations should result in the same side effect. Get, put, patch, and delete should return the same sorts of things. Post isn't idempotent because it's creating new resources, right? It is creating a brand new item and executing that multiple times is going to create more and more resources. It's not meant to be idempotent. Let's see what we mean in practice. So let's look at idempotency in practice. So this concept is really, really simple, but I want to make sure that you really understand what I mean by it. So every time I execute this operation, I should get the same result every time. And that may seem really simple, but that means that we might get different data back if something else in the system has changed that data. But if we, as part of a get, change this data ourselves, that means the get isn't idempotent. That means that this has side effects that REST tells me aren't a good design choice, right? What you really want to do is on this get, just return the current state. And if you do need to make an update, you would have a different API or URI to make that change, most likely in something like a put. Let's go ahead and follow the whole idea down. So if I say, get this request and make a new object, so this time we're on 29, because we deleted 28 in the last video, in case you don't remember. And I'll go ahead and make this change. Works fine, right? And so no matter how many times we execute this put, it's returning the same values, right? Even though the successive execution of this has no changes in it, it still returned the same object and said it was satisfied with it. This isn't about checking to see whether the update actually made a change or not. And delete, unsurprisingly, isn't idempotent either. Because right after you delete this, it's not going to be able to find that user. Now, it returned a 404, and it will forever now, but that doesn't count as idempotency because the operation failed. Let's talk about designing our results next. So when I talk about designing the results, I'm talking about designing the entities as you want to relate them. So in this example, just like we saw earlier, I have an ID, I have a company name, a contact, a phone number, and I can decide what this looks like. Now, in looking at this design, you could easily see that I could design this different way if it were useful, like having the address be a sub object or changing the names of some of these fields to be more less centric on North America, right? So city could be city or town. We've got state or province there. I'm using something like postal code instead of zip code because I want to be able to support this in different locales. So when you're designing these, think beyond the 12 customers that might be lined up for this API and think about it a little broadly. Don't over engineer. I'm not suggesting that. But if you think that in our case, our customers might need more than one address, maybe you go ahead and put address as a collection of addresses for this particular company. So when you're designing results, you want to think about the member names. And these member names shouldn't necessarily expose server details. This is especially true for when you're building an API on top of software that was written years or decades ago. I would go ahead and make sure those member names aren't the same names that are inside some old database that started its life as an access database. It also shouldn't expose technology biases, right? The way we name things that might be friendly to Ruby, Java, or .NET. If you're going to return JSON, go ahead and use camel casing because that's the convention. You're returning it as something that could be easily consumed by JavaScript. Even if you're not using JavaScript, that is where that design comes in. And if you don't agree with me and want to use your underscores, you want to use other naming conventions, it's not a problem. Just be consistent. Understand how the user of this API is going to need to look at this data and want to infer some things about it. If you use snake case and Pascal case and camel case all intertwined, it's going to confuse the user overall. So we saw the individual object that was returned. You can also think about designing collections in a better way. Here, for something large that will have paging involved, you might go ahead and have the results as a nested object and then have things that can help the user say things in the UX, like how many objects are total, what is the URI to the next page, etc. So don't be afraid to, instead of it being just an atomic resource that's returned, especially with collections, but some more information that will give them some context. Let's look at this next. So let's look at some different ways that you can design your results. We can see that if we just return our customers, we're getting pretty much just an array, and that each of those objects, as we've looked at before, has a certain structure to it that's fairly English in the way it works. In these sub-projects, this is also something you would design, and anytime you're going to return a project in this example, this should be consistent. We should be returning that same data no matter what we do. But if we look at another kind of API that is in our example, I'm going to borrow a little, but this time I'm going to get the collection of tickets. Now, this collection returns the results as a sub-object of actually an array of the results, but also gives information that could be used by the UX on how to deal with this. Because we have a large number, we might not want to return them all at once. And so while this URI returns the first 10, we could see that by just changing this, we're going to get the second 10, right? And in many ways, we don't need that page 10. It's just there to be explicit in my design. That's one of the decisions I made so that this would return, again, a set of them, knowing how to get back to the original page, knowing how to get to the next page, what page I'm on, and how big of a page size. And this is a great example where we're allowing that optional query string to be used to modify how we're doing this, right? So now we have page 2. Page size is 25, so we can expect that there's only going to be 4 pages, right? And so when you're designing this, I think it's important for you to think about how you can help your users do this best. Now, if you're just returning a simple collection, you don't need all of this ceremony. But when you're dealing with, let's say, a customer that's not in your company and you want to be able to enforce things like paging, This is a great way to do it. And it becomes intuitive because they can look at the result and know what they should be doing next. Let's talk about formats next. So during your design, you go on to think about what kind of format you're going to support. A lot of times, APIs are just going to support JSON as a default, but you might have other customers that need that data in different ways. The important thing is that you would abide by the accept header. So if you get an accept header here, and again, most of the frameworks handle this for you, if you ask for JSON, but you could take XML, then the server's job is to go, oh, I can do it in JSON. That was their first option. I'm going to return that. And normally these accept headers, the one MIME type application.json that we're going to return is going to specify that its content type is of that same type. I personally prefer not to use query strings for those formats because it doesn't really allow you to deal with a larger set of them. And you're going to really invent your own URI pattern for something that already exists. Accept and content type are two headers that are very commonly used. And this is specifically for what it is. So common formats you look at is JSON, probably the most common format. XML is still out there. And JSONP is a special kind of JavaScript that takes a callback parameter. That callback parameter means that it is executed and wrapped with basically a function that spits out those same values. Not very used much anymore. Alternatively, lots of applications are protecting their data formats through other means, like authorization tokens, for example. And you'll also see RSS and Atom. These are RSS feed formats. You'll notice they're both XML, but they include this specialization tag for RSS or Atom. Again, you're not going to see a ton of those, but as you look at this, these formats can be all sorts of things that may or may not be very open to other developers. But if you're building something internal in a company, you can deal with specialized formats if you think that might be helpful. My advice is to stick with the standard formats unless you really have a compelling case. Let's look and see how the accept and content headers work together. So let's look at the way we're formatting the results. If we come back into our example, let's do a get for our projects. And here it just returns a simple list of those projects. And because these are a little wide, I'll make it. And by default, because we're saying we accept JSON, it's going to return us JSON. And in fact, you'll see that the content type is JSON, though they've amended it with what character set these results are coming back in. So you'll see this character set UTF-8 pretty commonly as well, but you're really matching what this is to what the request accept header was, right? What if I change this from application JSON to application XML? This did the right thing, right? It returned content type application XML, and in fact, this is that same data in an XML format. This is an important idea because you can decide, you can let the caller of your API give you more information about how to fulfill this request. And headers are a great way to do that. And we'll talk a little bit more about this later when we talk about different kinds of headers that you may want to design into your API. Let's wrap up this module. So what have we learned? I've shown you that designing these APIs allows you to plan ahead for what the API looks like, not just run to your code and start coding and hope you're going to make those right decisions. Hopefully, I've convinced you that you should think about resources as your endpoints, not just queries to some data store. And that in designing an API, you're designing more than just the URI, you're designing the results of it, the format it can support, the content that you're returning to help your users do things in the most feasible way. Up next, let's talk about more advanced REST design.